Good morning, everyone. Good morning. Hope all is well and everyone's doing all right. So let's see where we are today. Radicals. Hold on, hold on. Yeah, I'll go ahead and let office hours be available for testing tomorrow. So if you want to come through. And so if you do decide to come through for those office hours, just remember that they are office hours. If you do decide to come in for testing, just remember that they are office hours. So we'll be talking. But you can always turn your volume down on that. But yeah, that's fine. That pretty much would be the thing. That's not a problem. As long as you come between 9 and 9:30, because I have a 11 o'clock class not to hit the road. Yep, not a problem, not a problem. So yeah, so that's the only thing I ask, that if you do come for testing, make sure you come between 9 and 9:30, and so that you have enough time to actually take your test, and that'll be fine. All right. But once again, if you want to take your test on another day other than that 9 o'clock to 11, Mr. Davis is an option. And then if you're talking about something else, then individual emails. We'll try to figure out what we can make happen for you. Let me check one thing before I go here. Why is my stuff not popping up? Sorry about that. So where is my 14 section? I'm looking at addition and subtraction. I just really need to relabel my stuff. We switch books, I never relabeled them. So there we go. Okay. Yep, so that's where we left off last class in here. All right. So here we go, 14.3, 14.4. We're looking at adding, subtracting rational expressions. Okay, so shoot me an email if you can't do it if you can't test Friday at 9 a.m. and you try to get in contact with Mr. Davis and nothing's happening on that front, then shoot me an email and we'll go from there. And we could discuss, options. Okay. Yeah. All right. So whenever you're adding, subtracting fractions, you need a common denominator. So that same thing holds true when you're dealing with rational expressions. And if you have common denominators, all you would do is add or subtract the numerator and numerators and then go from there. So in this first one, this was the problem. 2 over 7x cubed minus 9 over 7x cubed. We already have common denominators, so we can go ahead and subtract our numerators. So that will give us negative 7 over 7x cubed. Cancel the 7s, and that'll leave you negative 1 over x cubed. So just like with fractions, if you already have common denominators, just go ahead and add and subtract the numerator, add or subtract the numerators accordingly. Keep that same denominator and then reduce if possible. All right, so the next one, x over x squared minus 3x minus 28 minus 7 over x squared minus 3x minus 28. So we have common denominators of x squared minus 3x minus 28. So just subtract your numerators. Now there's nothing you can do with those numerators other than just bring them and make them one whole numerator. So x minus 7 are not like terms. So in the numerator, all you have is x minus 7. And then you can factor out that denominator into x minus 7 times x plus 4. We're doing that first one. So then the quantity of x minus 7 can cancel out, leaving you with 1 over x plus 4. All right, can I scroll up? All right here is the original problem. 3x plus 6 over x minus 6 plus x minus 30 over x minus 6. So once again, we have common denominators, so we can just add our numerators together. So we'll add like terms, 3x and x is 4x. 6 and negative 30 is negative 24. And then we can factor out 4 in that numerator. No, that'll give us 4 times x minus 6 over x minus 6. All right, x minus 6's can cancel, and that'll leave you with just 4. All right, any questions on that? So that's 14.3. That's add and subtracting your fractions with rational expressions with common denominators. So they give you the common denominators already. So you just add and subtract them accordingly and make sure you're okay with doing that. All right, so 14.4 and all of it, I just do both of those together just because they're the same thing, add and subtracting your rational expressions. But 14.4 is when you start having different denominators. So they want you to learn how to, find your LCD and all stuff like that. So is everybody doing this problem before I scroll up? All right, so let's find the LCD. So we look at both of our denominators and we want to factor them completely. So see right here, say factor each denominator completely. So x plus 4 is nothing you can do with that. And then x squared plus 2x minus 8. You can break that down to x plus 4, x minus 2. 4 times 2 is 8. 4 minus 2 will give you 2 in the middle. All right. And then from there, notice step number 2. So use each different factor seen. So we have x plus 4. We wouldn't write x plus 4 twice, but we have x minus 2. So that's why your LCD is x minus 2. All right, questions on what we did there, questions on the steps. So once again, step 1, you factor each denominator completely. Then for step 2, you use each different factor seen. So we use x plus 4 and x minus 2. You would not write x plus 4 twice. All right, can we go to the next one? Doing the same thing for this one, we have 4a over a minus 3, a plus 10 over a squared minus 9. Factor each denominator. So a minus 3 is nothing you could do with that. A squared is a difference of squares. So the a squared minus 9, excuse me, is a difference of squares. So that breaks down to a plus 3, a minus 3. And once again, use each different factor seen. So that's going to be x minus 3 and x plus 3. Once again, you do not use a minus 3 twice. All right. You okay to scroll up? All right, so here we have 16x over 8 minus x minus 8, and then 4 over 8 minus x. So denominators are x minus 8, 8 minus x. Notice right here, I just rewrote it with the x term first and the 8 afterwards. And don't forget to just keep your signs if you decide to do that. So x was negative, 8 was positive. And I did that so I can make a clean comparison between the two denominators. Notice that each one of our signs are opposite. And so in the box, notice what I said there, when you have opposite signs, when each one of your signs are opposite, um, you can just multiply it by -1. And you see that you get your x minus 8. So the LCD would just be x minus 8. Mm. All right. Any problems? All right, next exercise, they give you a fraction and said that it's equal to another fraction, but they don't give you, whether it be the top or the bottom, you're missing a piece of it. So they ask you to fill in the blank to make it an equivalent fraction. So you have to ask yourself, what is difference between the two denominators? What's different between the two denominators? You have AB, you have 9a squared b to the fifth. You want to know what would you multiply to AB in order to get, 9a squared b to the fifth. So that's the first thing you want to do is establish going from AB to 9a squared b to the fifth. What, made that transaction happen? What do you multiply to AB in order to do that? So this is one way of doing it. Go ahead and divide AB into that denominator of 9a squared b to the fifth and see what's the difference, or see what the quotient result is. And you see we have 9, excuse me, b to the fourth, 9a b to the fourth. All right. So if that's what you will multiply to AB in order to get that, whatever you do to the bottom, you have to do to the top in order to keep it equivalent. So that's why I said right here, you will multiply that to the -7. All right. So basically what it's saying is that in order to get the fraction, an equivalent fraction, you have to multiply top and bottom by 9ab to the fourth. So we multiply that to the 7, that -7, and we get -63ab to the fourth. And that is the answer. That's what goes in that box. Any problems before we go? We'll look at another one. So next one, same thought process. We have 2x over 2x minus 3. Then on the bottom, notice we have x times 2x minus 3 times x plus 9. And we want to know what will we put in the numerator. And notice the difference. You always got to compare this to this and say, what's the difference? What do I have over here that I didn't have initially? And you notice that it's x and x plus 9. At first, it was just 2x minus 3. And now over here, I have x and x plus 9. That's a part of my denominator. So that's what I did here, multiply top and bottom by x times x plus 9. Now we don't have to worry about doing the bottom because we want to know what goes here in the top. And so that's what we're doing here. We're going to distribute that 2x squared, because notice we had 2x, then we multiply x and x squared to the 2x. So x times 2x is 2x squared, and then we're going to distribute that into the x plus 9. So 2x squared times x is 2x cubed, and then 2x squared times 9 is 18x squared. Any questions? Any questions? Make sure we're okay.
So as long as we multiply by the numerator and factor that out, like how can we check and see, like, is there a way to verify your answer in this type of, not really, right?
Yeah, not really. I mean, all thing you can do is just make sure that you're multiplying by the right thing,
And
which
that you're
is,
factoring correctly,
yeah,
right? Okay.
yeah, pretty much, yeah. All right, got one more down here, like that anyway.
Just so I'm clear real quick, Mr. Tucker. So you
Yeah.
only multiply in the numerator what's missing in the denominator, right? The parts that's different.
Yes, exactly.
Okay.
Mm-hmm.
Thank you.
Yep. All right, so we have t over t plus 9, and the new denominator is t squared plus 7t minus 18. And so just like your classmate mentioned, trying to see what's the difference between each denominator, and then we're going to multiply that to our numerator to get the new numerator. So factor out t squared plus 7t minus 18. And you see that it gives us t plus 9, t minus 2. And if you have this situation, then of course t plus 9 is supposed to be a part of this. So that's a hint at, towards your factorization. You should get t plus 9 in there somewhere. And then the next part is what you need to figure out, the t minus 2. So multiply top and bottom by t minus 2 is what we're saying is done. The denominator is already done for us, but we need to calculate that numerator by distributing t to each term. And t squared minus 2t is our answer. All right, any problems?
I guess my last question would be, how come in the denominator you don't, I guess, solve that factor?
Okay, well, they already gave that to you. So,
Okay,
yeah, that's why only reason that all they want from you is to put into the
is that
box.
answer?
Mhm.
Okay. I
Yeah.
got
If in the event that you were to show that as a solved solution for the denominator, would that be counted against you?
No, well, see, in math lab, this is all they're gonna ask for.
Oh, that's all. Okay,
Yeah,
gotcha.
yeah. That box is, so they're just gonna say, what would you put in the box? And then so you would just be typing in this answer anyway.
Okay, great. Thank you.
All right, everybody good? All right, so let me erase some of this stuff. We can walk through it. All right. So let's look at this. The original problem would be this. So don't look at none of this stuff yet. We'll get to that in a second. So we have 3 over 7x squared minus y minus 1 over 21xy. All right. So we want to break down each one of our denominators and try to find that LCD that we talked about in the previous problems. So we have 7x squared y and we have 21xy. So there's nothing you can do with the 7, but the 21 you can break down into 3 times 7. So notice the first denominator, 7x squared y, we have 7x squared and y. Then 21, we have 3, 7, x, and y. So we're just breaking it up as much as possible, break it down to the prime numbers and go from there. So before we scroll down to establish what an LCD is, they're okay with what I did. I just looked at the 7x squared y. I didn't break the x squared down to x and x. Reason for that in a second, but I just did 7x squared and y. So we're looking at those 3 pieces. 21 can be broken down into 3 times 7. So we have 3, 7, x, and y. All right. So now when we're trying to find our LCD, remember we said we're going to take each different factor that we see. So when you're talking about in the first one, we have 7x squared y. So all 3 of those different. So I need to use all 3 of those. And then when I go to the next one, I see a 3. So I need to use 3. You know, this 7x and y I've already used, I got from the first one. And so if you have a power, you use the highest power. Notice we had x and x squared. So I used x squared. And so now you see what my LCD is. It's 7 times x squared times y times 3. And that'll give me 21 x squared y as my LCD. All right. So you break down each number, break it down as to, to each part, I should say. And then each different piece, that's going to be a part of your LCD. If there's a power involved, you take the highest power. And so that's why we chose x squared instead of that x. And that is your LCD. So before we go any further, is everybody okay with how we got the LCD? And of course, for the LCD, you multiply them together. We got 21x squared y. All right, so now once you've established what your LCD is, you're here. What you're saying is that you want each one of your denominators to be that. If you're saying that 21x squared y is your LCD, that means you want to turn each one of your denominators into 21x squared y. And so now we're about to do what we just did in those previous exercises, asking ourselves, what is different between 7x squared y and 21x squared y? Whatever the difference is, I need to multiply top and bottom to that in order to get the next fraction. Then do the same thing here. What's the difference between 21xy and 21x squared y? Multiply top and bottom in order to get the fraction. So scrolling up, did that right here. So if you take 21x squared y divided by the 7x squared y, notice the difference is going to be 3. So that's what I'm going to multiply to the top and bottom of the first fraction. And then 21x squared y over 21xy, the difference would just be x. So I'm going to multiply top and bottom by x. So it's the same exercise that we just did in the last few problems, just to establish, okay, what's the difference between the two denominators? Then whatever that difference is, you multiply the top and bottom to that so that we can have an equivalent fraction. All right, questions before we go back to the problem? All right, so that means I'm going to multiply. I was trying to stay color coded. Top and bottom here by 3. Here I'm going to multiply top and bottom by x. So 3 times 3 is 9. 1 times x is x. And then 9 minus x is just 9 minus x. Nothing you can do with that. So that is your answer.
Mr. Tucker,
Yep.
I'm not sure where along the lines I missed this, but so you solve at the very bottom 21x squared y over 7x squared y is equal to 3. Why is it you're taking that back up and applying that to the original problem? I guess I'm missing that somewhere.
Oh, not a problem. So the reason why you do this is because you want to know, what do I multiply to this in order to get this?
Oh, gotcha. Okay. Yeah, we're just trying to get the denominators the same. Okay. Gotcha. Okay. I was like trying to figure out where I missed it.
It's all good. All right. Any other questions before we go to the next one? So that's the foundation of what we're going to be doing for all the rest of them. That's how you add and subtract your rational expressions. So find the common denominator, factor them out first, see the different pieces. That's going to be LCD. Then what is the difference between your current denominator and that LCD that you want? And then you multiply top and bottom to that. Once you have your common denominators, go ahead and add and subtract your numerators accordingly. All right, so the next one, we have x minus 2 over x minus 4 plus 2x squared minus 15x plus 12 over x squared minus 16. All right, first move is to figure out what LCD is. So x minus 4 is nothing you can do with that as far as factoring is concerned. X squared minus 16, those are the difference of squares. So that'd be x plus 4, x minus 4. And so that means your LCD will be x minus 4 and x plus 4. Once again, you do not use x minus 4 twice. So essentially your LCD is the x squared minus 16. All right. So once again, you look at your denominator. I'm saying that this is my LCD. And if this is my denominator, what is different? So it's just x plus 4, right? Got x plus 4, x minus 4. I had the x minus 4 in in that denominator, I need to apply x plus 4 to it in order to turn to that LCD. And then this denominator is the LCD, so there's nothing you have to do to it. So when we go down here, I multiply both top and bottom by x plus 4 in that first fraction. Second fraction stays the same because, like I mentioned, x squared minus 16 is x minus 4, x plus 4. So that fraction didn't need to change. All right. So go ahead and distribute and FOIL out the x minus 2, x plus 4. That's x squared plus 2x minus 8. Now that we have common denominators, we can bring our numerators together. And I didn't combine like terms yet. I just went ahead and just brought them together. So it's x squared plus 2x minus 8 plus 2x squared minus 15x plus 12. So you just bring both your numerators together. Next step, we'll combine our like terms. Everybody good? All right, so combine your like terms. X squared and 2x squared is 3x squared. 2x and negative 15x is negative 13x. And negative 8 and plus 12 is a plus 4 in the back. Then you can factor. We have 3x minus 1, x minus 4 is what that numerator will factor out and give us. So there's no guarantee that it will always factor, but a lot of times it will because they want you to, have those extra steps. Make sure you factor completely. So x minus 4s will cancel. That'll leave you at 3x minus 1 over x plus 4 as your final answer. And your problems. Very good. So the next one be minus 3 over b squared minus 16 minus b over b squared plus 10b plus 24. All right. So just like before, take each one of your denominators, factor them completely, and then the LCD will be each different numerator that you have. So b squared minus 16 is b plus 4, b minus 4. B squared plus 10b plus 24 is b plus 4, b plus 16. I say 16, b plus 6. So the LCD is going to be each one of the different factors that you see. So you see b plus 4, b minus 4, and then b plus 6 are the three different factors that we see. All right, let's scroll up. So I wrote in black the same expression up here, but with the denominators factored, so we can cleanly see what needs to be added. We know that our LCD is this, but that first denominator is b plus 4, b minus 4. So I need to add b plus 6 to it. Hold on. Sorry about that, I had to sneeze. So, and then the next one we is factored out is b plus 4, b plus 6. So we need to add b minus 4 to it. So we just remember what we're doing is we take our denominator, compare it to what the LCD is, see what piece is missing, multiply that to the top and bottom. Any questions before we move forward? All right. So now we can go ahead and multiply that out. So we have b minus 3 times b plus 6. And that negative b times b minus 4. So that minus b needs to be a part of that distribution. So that's why I brought it all together first. So be careful with that. A lot of times people forget that minus sign right there. But that needs to be a part of your distribution. All right. So foiling that out gives you b squared plus 6b minus 3b minus 18. And then distributing a negative b will give you negative b squared plus 4b. All right, combine your like terms, b squared and negative b squared will cancel. 6b minus 3b plus 4b will give us 7b, and we still have that minus 18, which cannot combine with anything. So that would be your answer. Any problems, any questions? All right, everybody good before we go to the next one? So this one is x minus 9 plus 1 over x plus 9. So x minus 9 written as a fraction would just be x over 1. And so that means our LCD would just be the x plus 9. So to get that common denominator, we can multiply top and bottom by x plus 9. You know, like I said, that's our only denominator, so it's the only LCD. All right. Distribute x minus 9 into x plus 9. That will give you x squared plus 9x minus 9x minus 81. That's still over x plus 9. All right, 9 minus 9x will cancel. And then that negative 81 and positive 81, negative 81 and positive 1 will give you negative 80. So that's x squared minus 80 over x plus 9. Somebody said something. Okay, not a problem, not a problem. Any questions, any questions? Another one? All right. All right, can I scroll up? Very good. So original problem right here. 2 over 3t plus 5 over t plus 1. So there's nothing really to factor in either one of those. So you just go ahead and bring them together, 3t times t plus 1. That is your LCD. So I'm going to multiply top and bottom by 3t in the second one, and then t plus 1 in that first one. All right, distribute that 2, and then 5 times 3t. That'll be 2t plus 2 plus 15t. 2t and 15t will give you 17t plus 2. And that'll be your answer. All over 3t times t plus 1. Any problems? Any problems? Got one more. Want to make sure we're good though. All right, you scroll up. All right, so we have 7 over x minus 3 minus 9 over 3 minus x. So if you notice what we have here, when we look at our two denominators, we have x minus 3, 3 minus x. If I were to rewrite 3 minus x, write the x first so I can make a clean comparison between the two. Notice I have negative x plus 3. So both of my signs in each case are opposite. I have x, positive x, negative 3, and positive 3. So if ever I have that type of situation, the LCD is just going to be x minus 3. And what I can do is multiply that other one times negative 1 to change it into x minus 3. So multiply top and bottom by negative 1. And you only can do that if each one of the signs, you got the same expression, it's just that each one of your signs are opposite of the other. So once again, I have positive x and negative x, negative 3 and positive 3. So each one of the signs have to be opposite. So doing that will give me the common denominator of x minus 3. And up top, that'll be minus negative 9. Negative to negative is positive. So that'll be 7 plus 9, which is 16. All right, any problems? Any problems? All right. Everybody good? Everybody straight?
I guess my question would be, so if it was negative x plus 4, we wouldn't switch the signs because it's not the same?
Right. You would
Okay.
you would just go back to what we did in the previous ones. You had two different quantities and multiply top and bottom by that whole x plus 4 or whatever.
Okay, gotcha.
Mhm. All right. So that's it for 14.3, 14.4. We have two more sections out of 14 to discuss, which is 14.5 and 14.7. And we can do that, between, the next few classes or whatever. But so we don't have to do anything new today. And keep pushing, I should say. So before we close out, any questions on anything? Everybody good? So, and then just reiterating the fact that Friday, I'll just go ahead and make sure that is an opportunity for you guys to come in if you don't want to go through Mr. Davis. But like I said, if you cannot do 9 to, that between that 9 to 11 hour, feel free to either get with Mr. Davis, so that will always be available to you, or if for some reason that's not connected, check with me, and then we'll see what we can do outside of that. Other than that, you guys have a great weekend. Be safe. If you're coming on Friday, I'll see you tomorrow. Take care.
Have a great weekend.
Thanks. You the same.